This video explains the meaning of the probability density function in a normal distribution. The probability function in a discrete probability distribution represents the probability of each possible value of the random variable. For example, when rolling a die, the probability of getting a 1 is 1/6. In other words, the probability function px for a single die roll is the probability of getting the outcome x. However, in a continuous probability distribution, the probability that a variable falls within a certain interval is equal to the area under the distribution curve over that interval. Therefore, in continuous distributions, the probability density function is used. Instead of the probability function, let's look at the graph and probability density function of the standard normal distribution, which has a mean of 0 and a standard deviation of 1. In this distribution, what does the probability density function mean for a single value of x? In other words, what does fx0 mean? Of course, the probability density function has a meaning other than probability itself. Many people wonder what the probability density function in a continuous distribution really is, but it is rarely explained clearly in classes or textbooks. In fact, the nature of the probability density function is surprisingly simple and easy to understand. Now, let's clear up this mystery. In the figure, the probability that the random variable x is less than or equal to x0 is the area under the probability distribution curve to the left of x0. Let's denote this probability as gx0. When the value of x increases slightly from x0 by delta x, the probability increases by approximately the area of fx0 multiplied by delta x. In other words, gx0 plus delta x minus gx0 is approximately equal to fx0 times delta x. At this point, fx0 can be written as shown on the screen. As delta x approaches 0, fx0 becomes the derivative of gx at x0. In other words, fx0 is g prime x0. This holds true for all values of x. Therefore, when we differentiate the probability function gx, it becomes the probability density function fx. In other words, the probability density function fx can be thought of as the instantaneous rate of change of probability. The larger fx is, the greater the increase in probability, as the value of x increases. The material discussed so far comes from the book The Why of Mathematics. You can see part of the book cover on the screen. This book clearly explains many mathematical principles and formulas that are left unexplained in most math classes and textbooks. Depending on your needs and interests, even reading just a few chapters or topics in this book could make it well worth the price. This book is primarily for high school students and math teachers. The final few chapters of the book cover some fundamental math for science, engineering, economics, and business majors that are often skipped without explanation, making them useful even for early undergraduates. Refer to the description for a brief table of contents. You can order this book on Amazon.